Project 1, dealing with the NAE Grand Challenges, made by Jessa Smith, Bill, and Dong. An estimated 780 million people will go without clean drinking water each year. By solving this global issue, many lives would be saved, and we plan to accomplish this goal by using filtration and distillation to reduce the lead and the copper contents in the water. Filtration uses a filter to reduce the lead content in the water by almost 15% per minute. The distillation process will include heating the water at a high temperature, which will reduce the copper content at 5 milligrams per minute. Places all over the world are having this problem where they do not have enough clean drinking water for their population, causing many to suffer, and some even die every year. By filtering and distilling the lead and copper contents, these places, like Mexico City, Mexico, Kanpur, India, and Tokyo, Japan, these countries would all have different levels of lead and copper content, so we are able to take that information and provide them with the necessary ways that they need to distill or filter this water so that it will be clean for their population to drink. This will improve the overall health of the world, and everyone would have access to water, or at least larger quantities of people would. Larger engineering issues dealing with making clean water accessible are that some countries are poorer and they do not have the education needed to think of ways to distill water in cheaper ways.
This is Dong speaking. Firstly, our goal is to compare the lead and copper measurements in the drinking water with the actual standard drinking water in 2007. And the other goal for this dataset is to personalize the code. It was like we could create a code that contains user input that would ask for the lead and copper measurements. And we use the code to calculate their content in order to judge whether or not the water is suitable to drink. So for the algorithm, the first step we need to do is that to declare variables used in our code. And then we could load our dataset for lead and copper in 2007. Now for the step 3, we should ask the user input the level of the copper and input what's the lead. After that, we could check if input water is contains copper and lead. And then we should judge if the copper and lead levels is still higher than the standard or not. So for the step 6, we will use a for loop to let the dirty water go through our process. For step 7, if it is accept copper and lead, then it's going to be filtered and antivirus. And for the antivirus, we need to create an equation code and use it to reduce lead and copper content until to get the standard value. And then we could check the content if it is equal or less than standard value. So we need to add a while loop to record these times we need. And for step 8, we could add a graph to let user know the times they use that contain the antivirus value they get. Next, for step 9, we should use the for loops to tell user whether the water is reach our goal or not. If it's not, we need to rerun the process again. Lastly, for step 10, we need to extract the clean water which meet the requirement and to fprintf the output.
Hi, this is Bill speaking, and I'm going to read through our coding, and our topic is how to provide clean water. And the problem statement is focusing on a specific topic about how to reduce the content of the lead and copper in drinking water. Based on the dataset, we plan to use the filtration for reducing the lead content in water and the distillations to reduce the copper content in water. Our input will be a Excel which is shared with the 10 different countries and 10 different cities in 2007. The next two columns will be the sample corresponding lead and copper content with the country. The last two columns is about the standard form, the standard value of the copper and lead content in 2007. So back to our coding. The first method we're trying to do is the filtration. And in our design, the productivity is 100 mg total, and it will reduce 5 mg per liter per minute, which is like reducing 15% per minute. For the distillations, it's for reducing the content of copper in the drinking water. And when we heating the water, it will make the copper start precipitate. And we set it as a 5 mg per minute for the reducing. For our coding part, the first we're doing is check if the value has any negative number, because it was supposed to have all the positive number. So we use a for loop checking each row, each column, each element, and also we have to convert the string to the numbers in Excel. From the third column to the end. And if any number was negative numbers or incorrect, show a warning. And then we do the manual choice. Let the user to choose a city with the corresponding countries to check the lead and copper's content. And the next is our trace country is equal to the corresponding column in our dataset, and the trace the lead, the trace the copper is also equal to the corresponding dataset. What we're trying to do here is convert all the string to the real numbers. And the next we're gonna checking, like if all the tracing number is available or it's an incorrect number. So we said if the choosing lead or the choosing copper is less than 0, which is warning, it's a negative number, should be incorrect. And then after the data validation, we do another while loop, which is to testing the trace lead and the trace copper. And if the trace lead is greater than the standard value, then it go into our process doing the filtration, which will be reducing as 15% per minute. Until the trace lead reach the requirement, which is below the standard value, then it will stop and store the value. And the next one is do the copper. So the copper will reduce 5 mg per liter per minute. So every time when it runs, it's deduct 5 mg until it reach the standard value. It will store the trace copper. And we also say that count. Each time we run, the count will +1, and our times, which is like how many times the process ran and how many times our design, the water's doing the filtration until it gets the clean water. Next step, we're doing the figure, trying to plot the copper and the lead content, like how many times the lead and copper reached our standard value, below our standard value. We also do the X label for the times, how many times the process runs, and the Y label for the content of the lead, and another plotting is for the copper. And after we found the result, we do another check, like check our result if it's an incorrect number, and we also display. One, it's below the standard value, which means it is the drinking water. Then we display the condition of the lead, the condition of the copper is good and safe. But if it's not, if it's above the standard value, we provide another warning for the both lead and copper. And then we do a printf as our output, trying to say like which city you choose, which country you choose, and in which years we use the filtration or which method make the lead and copper content. This content are the final value, which should be less than the standard value. So next one, we trying to recheck our result. If our result is below the standard value, that should be right. So we do a double check. So the choice is for the which country. We do the same thing here, and stare into the numbers and find the corresponding lead and corresponding copper. And we do the count again, trying to say like if it's not below the standard value, how many times should we run our process again? And we do another while loop. Basically, it's the same thing like above 15% reduce, and this is the 5 mg per minute reduced. And the last step we're doing here is we check about the negative numbers again, because we want our final results is below the standard value and also greater than the 0. If it's a 0 or the negative number, that should be wrong. And so we do another data validations, and we printf the final result, like the saved country is which. If the number is right, it will printf like which country's water is safe, but if not, it will show a warning. So for example, let's doing a test case. When start, it shows all the manual tries, and let me try the cities, but it shows the plotting, which is the content and the lead content with the country's name, and the x label will be how many times does our process runs, and how many times the water going through the filtrations, and the y value will be the content. And in our comment window also shows the output, like the condition is safe or good, and which city we choose with the corresponding country, and which method we use for the lead and copper content, and how many times does the process run for the lead and coppers, and give the final value that after a couple times the country is safe or not. It's depending on the corresponding. And let's do another one. So last time what we choose is Beijing. Let's try to run again. Let's do top. Also give me the coppers, the lead, and we can see the lead in the drinking water in our process only runs like 2 times, and from the 0.12 reducing to the 0.102. And this is the copper content from Japan. It also runs the 2 times and reducing from the 17 to 12. Our comment window shows the lead content is safe, the copper content is safe, and which city and the corresponding country we choose, and which method we use, and that's for the final result. And how many times our process runs, and the most safe country is Iran.
This application could be used in the future to test drinking waters for poorer countries. Since this only uses heating water and a filter, this is very low cost, so that means that the poorer countries should be able to do this for their population. making everyone in that country healthier and have a better life as well. Some limitations for this project was it would work more efficiently if we were able to just take a sensor and put it right in the water. That sensor would tell us the copper and the lead content. From there, we would just input that straight into our code. It would eliminate data error and user error that may occur if the person was just inputting it like now. Another limitation would be with our water standards. So the more distilled that we take the water, the less accurate it will be.